Hi, everyone, and welcome to today's webinar. We're very excited to have you all here. My name is Jonas Roslin. I'm an open source community manager at VMware, and I will be your host today. Today's webinar is all about Kubernetes Cluster API, and with us to explain what that is and why it's critical to the future of Kubernetes, we have Andy Goldstein. Andy is a staff engineer here at VMware, where he works on tooling to make operating Kubernetes clusters easier. In his past lives, he worked on Velero, a disaster recovery tool for Kubernetes that we'll cover in a future webinar, and OpenShift. He lives in Rockville, Maryland, with his wife, 2 children, and 2 noisy cats. If you have any questions throughout the webinar here, please add them to the Q&A or the chat, and we'll answer them throughout the presentation. With that, I'm going to hand it over to Andy, who will kick things off.
Thank you, Jonas. Let me share my presentation here. Can you all see that?
Looks good.
Great. So as Jonas said, I will be talking about Cluster API today. So just a brief agenda here. I'm going to introduce myself and then move on to talking about what is a Kubernetes cluster, what does it mean to bootstrap a cluster. Moving on from bootstrapping, we'll talk about installation and then how Cluster API plays into all of this. And I'll end up with some next steps for the project and ways that you can get involved if you're interested. Okay, briefly about myself. I worked for Red Hat for a long time doing consulting, Java backend and front-end web development. I spent a couple of years developing a large messaging platform for the railroads. And then I shifted out of consulting to work on OpenShift 2, which is before Kubernetes, and OpenShift 3, which is based on Kubernetes. And that led me into containers and to Docker. And I became a Docker contributor to support some of the efforts that we were interested in for OpenShift, and namely the pull by digest feature. So if you've ever seen an image with a SHA-256 identifier, that was in part thanks to me. And I'm also a Kubernetes contributor. I did the initial implementations for kubectl exec attach and port forward. And I spent a decent amount of time working on Velero, formerly Heptio Arc, as the project lead. And today I am VMware's Cluster API lead. Okay, so what is a Kubernetes cluster? It's made up of actually a lot of things. You have to start first with infrastructure. So you need networking, firewall rules. You can't have anything without servers. And usually there'll be a load balancer involved for allowing external users to talk to your API server. After all the infrastructure is in place, you need to get your Kubernetes components set up. We'll talk about those in just a minute. There's add-ons that you may be interested in using. So for disaster recovery, we'd recommend something like Velero. For ingress, we have Contour for single cluster ingress, Gimbal for multi-cluster ingress. There's the Harbor Registry and Sonobui for conformance. These are just examples of some add-ons. You may have others that you're interested in as well. And then finally, the reason for running a Kubernetes cluster, user applications. These are the things that run in your enterprise, in your clusters, for your departments to power the applications or to be the applications that you need to perform your work. All right, let's talk about these Kubernetes components. They're very important. So when you are looking at a Kubernetes cluster, the first thing that you have to have is the container runtime. This might be Docker, Containerd, Cryo, or something else, but this is where what you're using to run your containers. Then you have the kubelet, which is responsible for taking the pods that you've defined and the containers that are in those pods and running them on a system. etcd is the database for Kubernetes. So all of your pods, deployments, config maps, everything related to all of the data types that you store and interact with for Kubernetes goes into etcd. The API server is the component that you interact with the most when it comes to creating resources and querying them. The kube scheduler is very important. It takes a look at all of the nodes in your cluster, the pod that you're trying to schedule, as well as its configuration details like affinity and anti-affinity rules, resource requests and limits, and it determines which node or nodes have the available capacity in the right place to be able to run your pod. The kube controller manager is a process that contains a variety of control logic necessary for Kubernetes as a whole to function. This includes things like the namespace controller, so that when you delete a namespace, as an example, it makes sure that all of the things in that namespace are deleted as part of the namespace deletion. The kube proxy component is important for inter-service networking. You also need a CNI provider, most likely, if you want to have pod-to-pod networking. And then there's core DNS for in-cluster DNS. So this is a lot of things. How do we bootstrap them? And by bootstrap, I mean configure. So there's going to be command line flags, configuration files, or some combination for each one of these things. And they're not always the easiest to configure. And some of these components have dozens or even hundreds of configuration options. So how do we do this? Some of the options include do it yourself. You could decide that you either want to do it by hand. Kelsey Hightower has Kubernetes the Hard Way, which is an excellent resource if you want to learn the ins and outs of how to get everything set up, but that's pretty manual. You alternatively, as part of the DIY option, could create your own scripts or find configuration management tools such as Ansible to set all of this up. There are also various installers that are out there that can take care of bootstrapping Kubernetes. But the problem with all of these is that there's no consistency or uniformity across all of these options. So we have kubeadm, which is something that provides consistent Kubernetes cluster bootstrapping. This is a project that is owned by the Cluster Lifecycle Special Interest Group, or SIG. This is a community of people in the Kubernetes ecosystem who are interested in cluster lifecycle. And what kubeadm does is it provides this consistent cluster bootstrapping experience. It uses a declarative configuration model. You can see there's init configuration, cluster and join configurations, and it provides some top-level commands like kubeadm init to create a new control plane node, or kubeadm join to join either a new control plane node or a worker node to an existing cluster. There's also phases that you can invoke that break down into individual actions. So basically, kubeadm is a building block. It's not the only thing that you need to have in your toolbox, but we have designed it to be fairly comprehensive when it comes to bootstrapping the components that you need for a Kubernetes cluster, but it doesn't handle infrastructure. So kubeadm is not the sort of thing that is going to create a virtual machine for you or set up your networking or anything like that. Which gets me to installation. So we have all of these things. We have the infrastructure, the Kubernetes components, the add-ons, the user applications. How do we go from nothing to a fully functional Kubernetes cluster, including all of the infrastructure that you need? So there's some options. You can do it yourself. This could be, again, writing your own scripts to provision EC2 VMs or Azure VMs or whatnot. If you look at kubeadm, again, it's just for bootstrapping and not for infrastructure, but it should be part of your installation experience. There are installers out there that will do both infrastructure and Kubernetes. These include things like Enterprise PKS or COPS. And then there's other installers that expect you to bring your own infrastructure, and they focus mainly on getting Kubernetes configured, which is something like KubeSpray. And then finally, you have managed Kubernetes providers, including things like Cloud PKS, GKE, for Google, EKS for Amazon, AKS for Azure, and so on. But when you look at this entire landscape of installation options, one thing that's clear is that you may need to use different tools for different environments. And that can be a problem if you're looking for consistency, if you're looking for something that's easy to understand and repeatable. So that brings me to Cluster API, which gives us declarative lifecycle management of Kubernetes clusters. And what do I mean by declarative lifecycle management? This is the ability to create, scale, upgrade, and delete your clusters, the machines that are part of your clusters. And declarative here means that we're using API concepts that everybody's familiar with if you know Kubernetes. So just like you can create a YAML file with a pod in it and send it to the API server, the goal here is to be able to do the same thing with clusters and machines and manage that declaratively. We have several GitHub repositories, but the main one is listed here as the Cluster API repo. A little bit of history on the project. I believe that discussions started around September 2017. There have been efforts such as Kubicorn to try and get some of these concepts laid out and implemented. And as these discussions were going on, they turned into a Kubernetes Enhancement Proposal, or KEP. This project is also owned by SIG Cluster Lifecycle, just like kubeadm. And as I mentioned before about possibly needing different installers to handle different cloud providers or bare metal situations, the goal of Cluster API is to be able to handle multiple infrastructure providers so that you don't have to go and find different tools for different cloud providers. It's been a long time coming to today. We had our initial V1 Alpha 1 API release for Cluster API at the beginning of April. And just like kubeadm is meant to be a building block for bootstrapping your clusters, we'd like to see Cluster API as a building block for getting the infrastructure set up as well as the bootstrapping. So Cluster API is not meant to replace things like COPS necessarily. Hopefully that these other tools that are out there that have a lot of popularity and traction in the field can adopt Cluster API over time so that everybody can benefit from these efforts. All right, let's go into an overview of what is Cluster API. So there are some custom resource definitions. These include things like clusters and machines, and I'll go over that in a minute. There's a lot of common logic that's in the Cluster API repository. And then we have provider-specific logic. So some of the providers listed here are the vSphere provider, which we call CAPV, the AWS provider that we call Kappa, the Azure provider, CAPZ, there's one for GCE, and there's a lot of other ones as well if you go look at the Cluster API GitHub repository. And looking at these custom resource definitions, there are 5 main ones that you'll work with. There's cluster, machine, machine class, machine set, and machine deployment. And before I get into talking about the specifics of each of these CRDs, I do want to just briefly talk about what it looks like typically to create a cluster. So normally you would start and you would have a management cluster that already has Cluster API installed. And once you have that set up, you can create a cluster resource, control plane machines, and machine deployments. And this will translate into potentially networking, firewall rules, a load balancer, and virtual or physical machines, depending on your provider. And you can do this, you can have multiple clusters, multiple sets of machines, all managed in the same management cluster. Okay, so looking at this cluster CRD, there's a few things in here that are common to any type of Kubernetes cluster. You'll have the pod CIDR or network range for pods, the service CIDR, and the service DNS suffix. And then what's left is really an embedded provider-specific configuration field. And I'll show you an example of this in just a minute. And then from the status side of things, you'll see API server endpoints, some error details if there were any errors. And then just like there's an embedded provider-specific configuration, there's one for status as well. So here is an example of what a cluster could look like for an AWS provider or Kappa. You'll see that it looks very similar to other YAML that you've seen for Kubernetes resources. It's got an API version and a kind. In this case, I've given it a name of demo1. I've specified the CIDR blocks for pods and services. I've given it a service domain. And then this provider spec down towards the bottom is that embedded provider-specific configuration. In this case, it's an AWS cluster provider spec, and I've specified my desired AWS region and the SSH key pair name as well. So what I'm going to do at this time, just because it takes a little bit of time to get these things spun up, is I'm going to go ahead and apply the cluster definition, and we'll get this going. So k-n demo1 apply-f cluster.yaml. And what you'll see in the bottom here is that there's a whole bunch of stuff happening. So I'm going to take this off the screen for a little bit and keep talking while the infrastructure is getting set up. So the next main CRD that you'll be looking at is the machine custom resource. So inside of the spec, you can specify what version you'd like to have for the kubelet and what version you'd like to have for the control plane. The control plane field is optional, and you would only fill that in if you want this particular machine to act as a control plane machine. And then similar to the cluster, there is an embedded provider-specific configuration or a reference to a machine class. And I'll talk about that machine class reference in just a minute. Once the machine has been created, you will see the provider identifier for that machine. So this would be an AWS instance ID, for example, and I'll be able to show that once we get a machine up and running. And there's a couple other fields that I list with an asterisk, the node taints and the kubelet config source, mainly because not every provider currently does anything with these, but the idea would be that if you specified either the node taints or the dynamic kubelet configuration source, that those would get translated and applied to the node or the kubelet once they're created. In the status, you'll see a node reference, which right now is not going to be filled in for my example cluster because of some limitations that we have in the project right now. And you'll see some other related things that would be useful for status, such as update times and error details and IP addresses. So this is an example of a machine, and this is my control plane machine that as soon as my cluster networking is up, I'm going to go ahead and create one of these. And this looks just like what you'd see for other resources. It's got a name. In this case, I'm also giving it some labels. So I'm telling it that it belongs to a cluster called demo1 and that its purpose or set is control plane. I'm also requesting that I want to use the 1.14.1 version of Kubernetes for the kubelet, and I want this to be a control plane node. And then similar to the cluster, there is a provider-specific spec. And here you can see that the instance type that I've requested is an M5 large. I have an IAM instance profile that I'd like it to use and an SSH key pair as well. So let me go ahead and we will apply this. So this is the same exact file that I just showed you. So I'm going to go ahead and apply that, and I'll pop that off to the side so we can wait for that to come on up. All right, machine class, while we're waiting here. So this is, it only has a single field for embedded provider-specific configuration. And this is meant to allow you to put commonly used fields in a single place so that you don't have to copy and paste them for every single machine. It's really used as a way to consolidate these provider-specific details into one place. And this can be referenced by a machine set, or a machine deployment. So it's just a handy way to avoid having to copy and paste everything. Next up, we have MachineSet. This is very similar to replica set. So you can list how many replicas you'd like to have of a particular machine. You can have a deletion policy. It's got a label selector, just like you'd see it in replica set, and then a template for the machine to create. And finally, rounding out the CRDs, we have machine deployment. This has a replica count, label selector, machine template, and a replacement strategy. And the replacement strategy is pretty important in terms of allowing you to do rolling updates, which I'll cover in a few minutes. And let me show you an example of a machine deployment here. I did have to compress this a little bit to fit on one slide. So you can see that in this example, I have 3 replicas. So that means I would like to have 3 machines created from this machine deployment. And I'd like kubelet version 1.14.1, and then the provider spec looks very similar to what I had for the control plane. So what I'm going to do at this point is come back over here, and we're going to go and see. First thing I need to do is grab my kube config for this particular cluster. This is something that is generated or can be generated on the fly. So what I've done is I created the infrastructure for my cluster. I created the control plane machine for my cluster, but in order to talk to it, I need my kube config. And so that's what this cluster cuddle alpha phases get kube config command will do. And I've already got my environment variable for kube config set to this particular file. So what I'm going to try and do is see if the nodes are available. And what you see here is that my node is not ready. The reason that it's showing not ready is that the way that the AWS provider for Cluster API works is it'll create a machine for you, and it'll create that first control plane machine like I've asked it to do. But what it doesn't do out of the box when I'm managing it like this is get the container networking interface set up. So I have an add-ons YAML that has Calico in it, and I'm going to go ahead and apply that. And you can see that there's a lot of things related to Calico that it created. And if we look at the nodes now and watch it, in a matter of a few seconds, it will get updated from not ready to ready. So we'll wait just a little bit for that to show up. There we go. So now we have one ready control plane node. So that's good, but it would probably be nice to have some regular non-control plane nodes as well. So what I can do is apply my workers YAML. And what this will do, oops, sorry, I did that in the wrong place. I need to go ahead and do that on my management cluster, which is this tab over here. And I'm going to go ahead and apply that. And you'll see that it created the machine deployment for me. And if I come in here and I ask it to look at the machines, now I have my control plane 0, which was the one that I originally created. And then I have 3 uniquely named machines that go along with my machine deployment. So if I move back to my demo 1 cluster and we look at the nodes, and I'll bring this back up in a minute and we'll be able to see that we're going to get 3 more. But while we're waiting, I will move on here and we'll talk about how do you start with nothing and get yourself a management cluster. And this is what we call the pivot workflow. And this is something that I wouldn't expect you to be doing too frequently, because the goal is to get your management cluster up and running and then use that as a means to create other clusters and manage them. But if you don't have anything, but you do have Docker and a laptop, for example, you can do this pivot workflow. And we have a command line tool that will allow you to do this. And so the way that this workflow works is it starts by creating what's called a bootstrap cluster using Kind or Kubernetes and Docker. And this is going to be running on your laptop. And the workflow will install all of the cluster API CRDs, the controllers, the actuators that you need that are specific to your provider, AWS in my example. All of this gets installed in the Bootstrap cluster. And then it will go ahead and create the necessary objects, essentially cluster and machine, to get the control plane node up and running. And once we have that cluster running in AWS, in this example, this workflow will take all of the cluster API, CRDs, controllers, the cluster and machine, and migrate them from the Bootstrap cluster to the real target cluster running in AWS. And once that's taken place, the tool will delete the kind Bootstrap cluster, and you're left with a real cluster running in AWS or your provider of choice. And this is the cluster that you would use for all future management tasks. In terms of the GitHub repository structure, this is something that can be a little bit confusing if you are new to Cluster API. So we have on the left here a list of everything that's in the Cluster API repository. So this includes all of the API types or CRDs, and then a series of controllers for clusters, machines, machine sets, machine deployments, and then a special node controller for Cluster API as well. And then inside a separate GitHub repository that's provider specific, you would find the provider API types, a cluster actuator, and a machine actuator. And there might be some other tooling as well, but in terms of how things are split in the repositories, this is what it would look like. And I do want to talk just a little bit about the difference between controllers and actuators. So the controllers will watch resources for changes. This means they'll watch a cluster, they'll watch a machine set, a machine deployment, and so on. The controllers that are in Cluster API provide some common logic. And then anytime that there's provider-specific logic, so provisioning infrastructure for a cluster, provisioning machines, that's where you have these things called actuators that have that provider-specific logic. So I want to talk just for a few minutes about the individual controllers and what their functionality is for. So the cluster controller will list and watch cluster resources. It will configure the clusters for graceful deletion. So that's some of the common logic that I was talking about. And then again, anytime there is something that's provider specific, it'll invoke a cluster actuator to reconcile the cluster, which basically means check if the necessary infrastructure exists, and if it doesn't, create it, and also check to make sure that it continues to exist and that people haven't changed it out of band. And then if you decide that you want to delete a cluster, the cluster controller will invoke the cluster actuator to delete it. The machine controller will list and watch machine resources. This will also, as part of its common logic, configure machines for graceful deletion, proper deletion order, and cascading deletion. And it will invoke the machine actuator, the provider-specific one, for creating the machine, updating the machine, and deleting it. The MachineSet controller is very similar to replica set, the difference being it acts on machines instead of pods. So it'll list and watch machine set resources, configure them for proper deletion order and cascading deletion, and it'll also adopt orphan machines. So there's no actuator associated with a machine set. It's totally generic behavior. So its sole purpose is to make sure that if you specify that you want five replicas of a machine, that there are 5 replicas. And if one of them gets deleted, it'll make sure that it gets scaled back up. And if there's too many, it'll scale it down. The machine deployment controller is very similar to a Kubernetes deployment. It'll list and watch machine deployment resources. Again, similar to the other ones, make sure that they have proper deletion order and cascading deletion setup. This one will manage machine sets and handle rolling updates, and it'll adopt orphan machine sets. In terms of rolling updates, this is a very, very important feature. So there's a couple of parameters that you can set that influence the behavior of a rolling update of a machine deployment. So you can set what is the maximum number or percentage of unavailable machines that you can tolerate. So you could decide, I will tolerate 1 or 3 or 10% that can be unavailable at any given time. And then on the opposite end of the spectrum, you have max surge, which is how many extra machines you're willing to allow beyond your desired number of replicas. And when you modify a machine deployment, for example, let's say you change the Kubernetes version, then, or the kubelet version, then the machine deployment controller will take the old machine set and scale it down based on the maximum unavailable that you're willing to tolerate. And it will scale up the new machine set based on the maximum surge. And it will keep scaling up the new one and down the old one until you're left with 0 replicas in the old machine set and all of the replicas in the new machine set. In terms of how Cluster API is deployed into a Kubernetes cluster, we use 2 stateful sets right now and not a deployment. The reason that we don't use a deployment is that when you update it, you could end up with multiple copies of the pod running simultaneously for a brief time. And with a stateful set, you're guaranteed that that won't happen. So the first stateful set that we run has the common cluster API controllers in a single pod, in a single container and process. This is the machine set, the machine deployment, and the node. So conceptually, this is similar to the controller manager, where it has multiple controllers running in a single container. This is exactly what we do with the first stateful set. And then the second stateful set will have your provider-specific controllers and actuators. So this is your cluster controller and actuator, and machine controller and actuator. So project next steps. We, as I mentioned, just came out with V1 Alpha 1 a little more than a month ago, and we've learned a lot since the initial discussions and then leading up to the time where we got V1 Alpha 1 released. And so right now, we are working in the community to refine the architecture so that we can share cluster bootstrapping logic across infrastructure providers. Today, when you use Kappa or CapV or CapZ or any other provider, they are all responsible individually for provisioning a machine and bootstrapping it so that Kubernetes is installed and running correctly. And one of the things that we are working on is seeing if we can extract that bootstrapping logic and make it common so that all of the different infrastructure providers can take advantage of that rather than having to implement it themselves. We're also focusing on node and control plane lifecycle management, including upgrades. So right now, when you create a control plane, especially if you want a highly available control plane, we recommend and encourage you to use machines instead of machine sets or machine deployments, because you have to be very careful when you are managing etcd quorum, for example. And you can't just add and remove members at will the way that the rolling update of a deployment potentially would do it. You have to be very careful so that you don't lose quorum. And we are hoping to add some orchestration around control plane lifecycle management to be able to handle that. We're also interested in working on common tooling to create VM images for multiple infrastructure providers. We would like to have a single place where you can or a single tool where you can end up creating images for AWS, Azure, vSphere, and so on without having to go use a different tool per provider. And we're targeting a V1 Alpha 2 sometime later this year. The exact date is TBD. All right, I'm going to take a little break from my slides and go back to the demo here. I've been watching the nodes here, and if we take a look, we'll see that there are 4. So we have the 1 control plane node and 3 worker nodes. And I can do something like run a busybox image and get a shell up and running just to show you that it will run. And here you can see my shell, and I can ls, and I can do a curl, or I can't do a curl, but I can do an ns lookup maybe. And so we have networking working. So basically, oh, I guess I don't have networking quite working there, but I do have a running pod in my cluster. and I can go ahead and get out of there. So I have a functional cluster. It's got three worker nodes, and if I wanted to, I could scale it up or scale it down. And then if we go back over to the management cluster and we ask it for a view of our clusters, we can see that I have this one called Demo 1. And one of the things that I did want to show, let me just resize this down a little bit, is if we look at this in more detail, you'll see that the provider spec has a lot more things than I originally put in there. So there's some CA key pair information, there's other key pair information, and then there's a lot of details about subnets and availability zones. All of this stuff was created by the AWS provider and not anything that I had to worry about. So that was really nice. And then similarly, if we go and look at the machines, what you'll see, these don't have as much detail in them, but you will see that there's a provider, whoops, sorry about that. You will see that there is a provider ID for the machines, and there's some kubeadm information as well. But each of these machines, as we go through, again, has the provider ID filled in. And so you can just, that it's running. And if you go to your AWS console, for example, you can go look at that and get more details there. Okay, so how can you get involved in Cluster API? Step number one, try it out. We definitely encourage everyone to take a look at the GitHub repositories, read the documentation. If you have cloud provider access, try it out. And again, it's V1 Alpha 1, so there's probably some bugs somewhere lying around. So please file bugs if you run into them. We have community meetings for the Cluster API project as a whole on Wednesdays. So please try to join those if that time works for you. If you have feature requests, feel free to add them. And pull requests for fixing bugs or adding features are certainly welcome. And in terms of all of that, I have links here. We will, I'm assuming, send out this slide deck so you can click through on all of these, but we have links to the cluster lifecycle SIG, the overall cluster API project, links to the weekly meeting minutes, our Discuss community forum. We have documents in the repository on the project scope and objectives and use cases, and we have 4 work streams that are working actively right now to define what V1 Alpha 2 will look like. And these are, what is our extension mechanism going to be? So if you're trying to write a provider, would you write it with CRDs or webhooks or gRPC or some combination? Are there any refinements to the data model that would make sense to make? And then finally, control plane and node lifecycle management. And then I also have links to 3 of the main providers that my teams have been working on. So at this point, Jonas, I will turn it back to you for some Q&A.
Sounds good. Thank you so much, Andy. Lots of great information here. So thank you so much. We do have a few questions. The first one from Rajib. They were asking if they could have the YAML files shown in the demo.
I certainly can do that.
Awesome. So we'll share that later. This recording will also be up on YouTube, so all the links will be in the YouTube description there too. Got another second question here from Ramiro. You talked about upgrades, so rolling upgrades of your machines. How would you run a rollback from an upgrade?
So in theory, you could just change the version back, and I'm not positive off the top of my head. We may have a rollback mechanism as well, similar to what you'd find in deployments. There may be some issues if there are changes to the etcd database. If you're doing a control plane upgrade and that includes an upgrade to etcd, you may not be able to roll back. So we always recommend that if you're doing something where you're afraid that the upgrade might fail, if you're using virtual machines and you can snapshot them, that would be advisable. We also have tools like Valero that I mentioned before, where you can take a backup of your critical aspects in your cluster, including your persistent volume data, and then potentially restore from a Valero backup if necessary.
Awesome, thank you. I hope that that answers your question there, Ramiro. I have another question here. So there's a bunch of infrastructure that comes into place here for with a Kubernetes environment. So you showcase the control plane machines. Can we provision other infrastructure that I need for Kubernetes clusters here as well, like load balancers, things like that?
That's a really good question. So one of the non-goals of the Cluster API project is to provision and manage infrastructure unrelated to running Kubernetes clusters. We don't want to be another Terraform. There are tools like Terraform that are, you know, good for that sort of thing. So if you need a load balancer and it makes sense in the context of running your cluster and for that whatever provider you're on, then I would expect the provider to handle that load balancer, just as an example. But if you're looking at, I don't know, maybe you want an AWS SQS queue setup, that's not the sort of thing that Cluster API would be responsible for. So if it's application level infrastructure, so you're planning on deploying pods into a cluster and the code that's running in your pod needs a queue or an S3 bucket or something like that, then that's out of scope for Cluster API.
Okay, thank you. I have one more question here. So you showed how you managed a cluster of machines there. Is there a limit of some sort on how many clusters you can create using Cluster API?
I would say the only two factors would be whatever your provider imposes upon you, if there's any limits there. Plus, there are theoretical limitations in etcd with how many objects you can put in there, but I can't imagine that you would run into those limitations before you would run into cloud provider limitations or money issues if you're on a commercial cloud provider where it costs a lot of money to run you know, hundreds or thousands of machines.
Awesome. So you put a bunch of links here for people to get involved. You will also be in at KubeCon in a couple of weeks, right?
That's right. Yes, I will be at the Contributor Summit on Monday for the Cluster Lifecycle face-to-face. And if you're unable to attend Contributor Summit, I'll be there the rest of the week. I'll be at the VMware booth and lounge and roaming around as well. So feel free to come and find me and chat.
Excellent. Thank you so much, Andy. We got one question here from Kumar. Is creation of infrastructure like service load balancer in scope for Cluster API? Oh, I think that was just answered. Yeah, I think that's it for today. Thank you so much, Andy, for all this wealth of information. We'll make sure everyone gets a copy of the presentation and the YouTube recording and everything. Thank you so much for everyone who attended, and I hope to see you all soon at another webinar.
Thank you.
Have a great day. Have a good one.